So right here we have a reaction where you can take some carbon monoxide gas and some hydrogen gas, and when they react, you're going to produce methanol. And this is actually pretty interesting. Methanol has many applications. One of them, it's actually race car fuel. But what we're going to do is study how much methanol we can produce if we have a certain amount of carbon monoxide and molecular hydrogen. So let's say we have 356 grams of carbon monoxide and 65.0 grams of molecular hydrogen. Pause this video and based on this, figure out how many grams of methanol will we produce. Well, a good place to start is by converting these numbers of carbon monoxide, this amount of carbon monoxide and molecular hydrogen, into moles. And so to do that, we can take out a periodic table of elements, and the molar mass of carbon monoxide, you can look at the molar masses of carbon and oxygen and add them together. So 12.01 plus 16, that is going to be 28.01 grams per mole. And if we want to convert to moles, we're going to have to multiply this times moles per gram. And so for every 1 mole, we just figured it out, 28.01 grams. And this is going to be approximately equal to 356 divided by 28.01 is equal to, let's see, and we have 3 significant figures here and 4 here, so I'll round to 12.7 moles, approximately 12.7 moles. And then we could do the same thing for the molecular hydrogen. And here, we're going, for every 1 mole, how many grams, or what's our molar mass of our molecular hydrogen? Well, each hydrogen atom is 1.008 grams per mole, but each molecule of hydrogen has 2 hydrogens in it, so it's going to be 2 times this. So 2.016. 2.016 grams per mole, or 1 mole for every 2.016 grams. And so this is going to be approximately equal to, get the calculator out again, 65 divided by 2.016 is equal to that, and we have 3 significant figures, 4 significant figures. So if I round to 3, it's approximately 32.2 moles. So 32.2 moles. And so the first thing to think about is, in our reaction, for every 1 mole of carbon monoxide, we use 2 moles of molecular hydrogen, and then that produces 1 mole of methanol right over here. And so, however much carbon monoxide we have in terms of moles, we need twice as much hydrogen. And so we see here molecular hydrogen. And so 2 times 12.7 is going to be 25.4. So we actually have more than enough molecular hydrogen. And so we are going to use 25.4 moles of molecular hydrogen. How did I do that? Well, it's going to be twice the number of moles of carbon monoxide. Twice this number right over here is this right over here. And we can immediately see how much we're going to have left over. We're going to have left over 32.2 minus 25.4 is 6.8. 6.8 moles of molecular hydrogen. And how many moles of methanol we're going to produce? Well, the same number of moles of carbon monoxide that we're using up. It's a 1-to-1 ratio. So we're going to produce 12.7 moles of methanol. And so let me write that here. So if I have 12.7 moles of methanol, CH3OH, how do I convert this to grams? We'll have to multiply this times a certain number of grams per mole so that we can cancel out the moles, or essentially the molar mass of methanol. And to figure out the molar mass of methanol, we'll get our calculator out again. So we have 4 hydrogens here. So 4 times 1.008 is going to be that. And then to that, we're going to add the molar mass of carbon, because we have 1 carbon, plus 12.01, and then plus 1 oxygen in that methanol molecule is equal to that. And let's see, we will round to the hundredths place because our oxygen and carbon molar masses only went to the hundredths place here. So 32.04 grams per mole. So we have 12.7 moles times 32.04 grams per mole will tell us that we are going to produce that much methanol. And let's see, we have three significant figures, 4, so I'll round to 3. So approximately 407 grams of methanol. 407 grams of CH3OH. Now the next question is, what's the mass of hydrogen that we have left over? Well, we just have to convert our moles of hydrogen that we have left over to grams, 6.8 moles of molecular hydrogen, times the molar mass here in grams per mole is just going to be the reciprocal of this right over here. So times 2.016. 2.016 is going to give us this right over here. And if we were rounding to two significant figures, which I have right over here, that is going to give us approximately 14 grams. Approximately 14 grams of molecular hydrogen is left over. Left over. So we used a good bit of it. We used about 51 grams, and we have 14 grams left over. And it was carbon monoxide that was actually the limiting reactant here.